Composition and inverses. So just a reminder, f to the negative 1 of x represents the inverse of the function f of x. And another reminder, an inverse reverses the action of a function. So if we have two functions, f of x and g of x, we can check if they're inverses by checking if f of g of x equals x and g of f of x equals x. In other words, their composites bring us back to where we started with the input x. So let's look at an example. F of x equals 2x plus 3, g of x equals x minus 3 all over 2. So are these two, f of x and g of x, are they inverses? Let's check f of g of x. Let's start by writing the f of x function, 2 times something plus 3, and substitute the g of x function in for x, so x minus 3 over 2. Let's start simplifying. We'll multiply 2 times x minus 3 all over 2 and get x minus 3, and we still have the plus 3. And then combining like terms, the negative 3 and the 3 combine to form a 0, so this equals x. So f of g of x equals x. But it's not enough to just check the 1. We also need to check g of f of x. So let's start by writing the g of x function. So something minus 3 over 2, and we'll substitute in our f of x function, which is 2x plus 3. Our numerator simplifies to 2x, and we're dividing by 2, and this simplifies to x. So here, g of f of x also equals x. So since both f of g of x equal x and g of f of x equals x, then yes, f of x and g of x are inverse functions. Let's look at another example. F of x equals x squared plus 7. G of x equals the square root of x plus 7. So let's check f of g of x. Start by writing the f of x function, something squared plus 7, and we'll substitute g of x in for x, so we'll write in the square root of x plus 7. Now if I start simplifying, the square root of x plus 7 squared is x plus 7, and I still have to remember my plus 7 that's already written in that function. So x plus 7, combining my like terms, I get x plus 14. This is not x. So f of g of x does not equal x. Therefore, f of x and g of x are not inverses. Let's look at one more example. So here, f of x equals x squared plus 7 again, but now g of x equals the square root of x minus 7. So let's check f of g of x. Let's start by writing the f of x function, something squared plus 7, and then we'll substitute in the g of x function for x, so the square root of x minus 7. Simplifying, if we take the square root of x minus 7 and square it, we'll end up with x minus 7. And I still have my plus 7. And now if I combine like terms, my negative 7 and my positive 7 combine to form a 0, and we're left with x. So f of g of x equals x. Now, we do need to still check g of f of x. So let's check g of f of x. Let's start by writing our g of x function, so the square root of something minus 7, and we'll substitute in f of x for our x. So x squared plus 7, simplifying under the radical, the positive 7 and the negative 7 combine to form a 0, and we're left with the square root of x squared, which simplifies to x. So here, g of f of x equals x. So since f of g of x equals x and g of f of x equal x, then f of x and g of x are inverses. And just to remind you that there is the second notation, we could have also written f of g of x equals x and g of f of x equals x using that open O, but smaller than an O, that symbol for a composition.